Good morning, everyone. It's Mrs. Wallace from the couch. I'm sorry to say that I have COVID, so I am not going to be in school probably today, probably tomorrow. I'm not sure about Wednesday, so I will keep you posted. In the meantime, we do have some topics that we definitely have to cover in econ, so I wanted to do this video. And what I'm asking from you is if you can watch the video, address any questions that you have, and make sure, let me know what questions you have, and also do some of the practice problems that are attached or in the slideshow. That would be great because then when we all get back together, we'll kind of be on the same page. And for some of you who have to make up the quiz, if you were absent or whichever for the quiz on Thursday, let me know and we'll schedule that as best I can. If I can have another teacher give it to you, we can try to do that. The other thing I want to say is the assembly on Friday was awesome. I saw you up there. So, Stacy and Innocent, Januka, there were tons of you up there dancing. It was great, really, really great. So, you should feel good about the assembly. One thing that we're going to be doing today on Monday is just reviewing a little bit of the long run for just a few minutes. This is going to be super quick. And then offering some practice questions. So there'll be some practice questions in the slideshow to take a look at just to see how comfortable you are with the content. And then also I will post the answer key for the handout that you had last class where we worked on the long run. And then lastly, I will post some questions on AP Classroom for the long run. So that's like kind of just capturing some of the content that we already did, but just to remind you, because it's been a couple of days. The second video I'll post today is an introduction to implicit and explicit costs. It is a topic that is short, mostly informational, vocabulary type content, and a few practice problems for that. I'll also leave the pages in the textbook for that topic that you can pursue and practice additional problems. So all of those instructions will be on Schoology, and it should be something that you can complete during the class period, okay? So if you recall, the long run is different than the short run. Short run cost curves are shaped because of primarily the law of diminishing marginal returns. Some of them, are related to the shape of the, average fixed cost as well. But in any case, the long run is really different because there are no fixed costs in the long run. That is the definition of the long run. All costs are variable. And as we noted in class last time, we develop kind of a smooth long run cost curve by examining the minimum points of multiple ATCs, multiple possible cost curves based on a variety of different resource combinations. So you can think of this as a firm that might imagine itself really, really small. So a small bakery that's happening, largely in a strip mall somewhere, and then they decide to plan for what their average total cost might be, say for each apple pie that they produce, and they're interested in how that average total cost will change as they produce more and more and more pies, maybe with 4 different bakeries and 20 ovens instead of 4 and 80 employees instead of 10 or whatever it is. So all these various combinations of resources can offer, a decrease in average total cost. And so for firms that are seeking to increase their output, they want to know, well, if I am going to make, 600 pies rather than 60 pies, what would be the best combination of resources that I should utilize, and especially as firms consider, should they automate, should they purchase additional ovens, should they hire additional employees, when does it make sense to do that? Okay, so that's what this is about. All the possibilities. We did talk about economies of scale and diseconomies of scale. I won't go through all of the reasons why that can be the case, but economies of scale by definition is when you have a decreasing ATC over greater and greater and greater quantities. Okay, so the more a firm makes, the lower the average total cost would be. That section of the curve that's literally downward sloping, that's going to be the economies of scale. And this happens because firms get really, really efficient, specialized, able to produce at a lower average total cost. Okay. And sometimes the benefit of being big enables greater economies of scale. Okay. So scale sometimes in and of itself creates the ability to be more efficient. Diseconomies of scale would be an upward sloping long run average total cost curve. This would be where over greater and greater quantities, the average total cost is actually increasing for a good, say pies. And this is because of, it becomes harder and harder to coordinate resources, maybe communication problems, maybe workers are not being productive, work from home, whatever it might be, 1,000 different things that can create diseconomies of scale. We also noted these definitions of increasing returns to scale, decreasing returns to scale, and constant returns to scale. Remember, these definitions are different. Increasing returns to scale implies economies of scale and a downward sloping curve, but technically it means if you increase your inputs by a certain percent, let's say 20%, your outputs increase by a greater percent, that's increasing returns to scale. Decreasing returns to scale, your increase in inputs yields a lower increase in outputs, and constant return to scale, a 20% increase in inputs yields a 20% increase in outputs. We can graph that and showcase what that looks like. It's just a different way of articulating what's happening when firms are producing efficiently, okay? And this is in terms of output rather than in terms of ATC. One other thing we didn't get to talk about last class, so this is kind of like where you can perk your ears up a little bit, is the concept of minimum efficient scale. If I was a firm that said, listen, I know I want to produce my pies where they're cheapest to produce. I really want to take advantage of where my average total costs are lowest. What would be the lowest quantity that I need to produce in order to achieve that minimum kind of point on my long run average total cost curve? And the minimum efficient scale can be kind of important. So if we look at this graph here, this is a very typical graph for the long run average total cost curve. And you can see very, very typical, kind of curve here where we have economies of scale, where you see ATC is decreasing up to Q1. Between Q1 and Q2, we have constant returns to scale, okay? This suggests that you increase your input, 50%, and your output increases 50%. The lowest point, the minimum efficient scale, the lowest quantity that I could actually produce and still benefit from the lowest ATC would be Q1. I could produce Q1 or I could produce Q2. At both of those points, my ATC is the lowest that it could possibly be. If I'm interested in minimum efficient scale, I would produce the quantity Q1. As soon as I produce quantities that are lower than Q1, my average total cost will be a little bit higher. I would be experiencing economies of scale, but I haven't maximized my economies of scale. After the quantity of Q2, long run ATC also starts to increase, and as a result of diseconomies of scale. Okay, and just kind of keep in mind what's on the X and the Y axis here. When we're graphing long run cost curves, we're looking at average total costs. Okay, so the dollar amount of the cost would be on the Y axis, and the output would be the number of pies, right? And minimum efficient scale is where we see Q1. That would be the quantity of pies that you'd produce to be minimum efficient scale. Sometimes this can tell us a little bit about an entire industry. This is an industry where you might have one firm that has massive economies of scale and produces a really significant amount of output. Okay, this is like the long run ATC for a utility company or a power plant that has really high fixed, well, not fixed, let's say capital costs in the long run. So we won't use fixed costs, but really high capital costs, upfront costs. All of those costs have to be in some way kind of addressed based on increased output. And because this is a firm that can benefit from economies of scale, you might see one firm that serves a large amount of that output because they are benefiting from the scale, like one utility company. You're not going to have 20 utility companies competing with each other to provide, some type of, heating or electricity in a town. That would be one firm that organizes that kind of good for many, many, many people, because the more people they serve, the lower it is per unit of utility. Okay, you could look at a different type of industry. Okay, something that looks a little bit more like this. This could also be a long run ATC. And this just showcases a much different economy of scale. And the output is very different. You might have many firms producing at that lowest point, and they might be competing with each other. Okay, so, this can tell you a little bit about, some industries are shaped in a way that it's natural to have very large firms and few of them. Some industries are shaped where, like retail, for example, or furniture stores or whatever, there might be tons and tons and tons of them. And sometimes the long run cost curve can help us see where and why some firms might produce a small amount of quantity and some firms might produce a really, really large amount of quantity. It depends on their long run average total cost curve. Okay. One additional thing to think about is sunk costs, and this will be the last slide. Oh no, I have the practice questions, but this is like the last, talking slide. You've probably heard of sunk costs, and if not, you've probably heard of the expression, don't cry over spilled milk. Sunk costs, economists disregard. These are costs that have already been incurred, and they are irrecoverable. So they don't really affect any decision that you make because we use marginal analysis. Costs that you've already paid should be, what we would call like water under the bridge, right? They shouldn't matter. So say that you paid a lot of money for concert tickets, right? You paid tons of money. I like the Dave Matthews Band. Say I paid a ton of money for those tickets and I'm ready to go to the concert. Maybe I spent $100 on a ticket and it's pouring rain. Okay, so I then look outside and the concert's outside, decide, well, I don't know if I really want to go or not. But our intuition is kind of saying, well, I paid $100 for the ticket. I've got to go because, it's got to be worth my $100. An economist would say, don't think like that. That money is already spent. You can't get it back. So it's not really part of your decision. It's a sunk cost. What really matters now is the marginal cost of going to the concert, sitting in the rain, and the marginal benefit that you get from watching the band play. Make your decision based on that marginal benefit and marginal cost, and don't engage in sunk costs. And, it's not bad advice because a lot of times we, tend to deliberate over things, that have already happened, and it's not necessarily relevant to the current decision. Okay, so just a reminder from economists. Let's do a couple of practice multiple choice questions, and then we'll open up some AP classroom questions for the long run for you. Just good practice for you. So here we have a question. A farmer produces bee pollen using two inputs, labor and land, whose prices are constant. If she doubles her inputs and she finds that the quantity of pollen produced more than doubles, so in this case, if she doubles her inputs and she finds that the quantity of pollen produced more than doubles, we would call that increasing returns to scale. So if the question asked about that, that's what's happening here. Therefore, it must be true that in this output range, her long run average total cost curve is increasing returns to scale implies incredibly efficient production. This suggests that each next quantity is going to be a lower ATC than before. So this is also economies of scale. Increasing returns to scale implies economies of scale. So this would be an ATC that is downward sloping, at least for the section of the cost curve that we're interested in this output range. It may not consistently be downward sloping, but within the output range. So the correct answer would be B. Okay, let's look at the next one. The long run average total cost curve consists of minimum points of the short run ATC curves for firms of various sizes, maximum points of the short run ATC curves for firms of various sizes, average variable cost curves for firms of various sizes, marginal cost curves for firms of various sizes, and marginal product curves for firms of various sizes. The correct answer is A. It is the minimum points of the short run ATC curves. The long run average total cost curve is comprised of short run average total cost curves. Okay, never anything else, not variable cost, not fixed cost, not marginal cost. It is always going to be minimum points of short run ATCs, and it could be any number of short run ATCs. Minimum points enables us then to create a smooth long run ATC curve. Which of the following must be true if a firm is experiencing economies of scale? All costs are explicit. We haven't even learned explicit costs yet, so it's not A. Long run average total cost decrease as the firm's output increases. That sounds good. That is the definition of economies of scale. It cannot be C because economic profits decrease as the firm's output increases. That is, we are not at all connecting cost to economic profit. They're not related at all. They're related, but they're not the same thing. Long run average total cost remains constant. That is not the case. That would be constant returns to scale instead of economies of scale. And proportionate increase in inputs results in less than proportionate increases in output. That would be a situation of decreasing returns to scale and diseconomies of scale. The last one, economies of scale occur as a result of labor specialization. Definitely. Labor specialization is a situation where maybe workers have been trained, educated, received some sort of additional capital resource. Now they are able to focus on one particular task. An example of this is Ford and the assembly line. Later on in history, McDonald's creates a very specific structure for fast food, very specialized use of labor, and that creates economies of scale. Management specialization, definitely the ability to have larger firms enables a great deal of very qualified, specific management, human resources, research and development, marketing, all kinds of things like that. Worker alienation, that is not an example of economies of scale. That would be diseconomies of scale. And efficient use of capital. Of course, that is economies of scale. Efficient use of capital, if you think of Amazon and their use of labor. Of course, they're criticized for this because they use their labor in such a way to maximize efficiency. It creates a lot of labor issues, which is certainly an issue. The efficient use of capital also in Amazon with like robots and, the ways in which they've combined the resources to try to find, low cost production, okay, would be an example. Alrighty, so that's a little bit about the long run. The next video will be an introduction to implicit and explicit costs. So we'll kind of note that and offer a couple of problems for you for that. And that'll be it for today.